we present our work, Reloc3r, large-scale training of relative camera pose regression, for generalizable, fast, and accurate visual localization. Estimating camera poses from images is a fundamental problem with diverse applications, such as mixed reality, robot navigation, and artificial general intelligence. In this work, we focus on relative pose estimation and visual localization. Specifically, relative pose estimation determines the camera pose between an image pair, while visual localization solves the query pose against a pre-registered database. Existing works in visual localization often involve trade-offs among generalization ability, test time efficiency, and camera pose accuracy. Recently, thanks to large-scale training, the emergence of large foundation models has demonstrated promising generalization, efficiency, and accuracy for many vision tasks. This motivates us to develop a large foundation model for camera pose estimation. We follow the principle of parsimony and choose the methodology of camera pose regression, which enables efficient large-scale training. We named our method Reloc3r. It consists of a relative pose regression network that estimates poses between image pairs, and a minimalist motion averaging module that aggregates relative poses to estimate absolute poses. The key design features of the network are twofold: a fully symmetric Siamese network that uses shared parameters while maintaining accuracy, and we chose to learn camera poses without metric scales, which facilitates generalization across different datasets. We have processed approximately 8 million image pairs from 7 public datasets for training. For supervision, we apply simple angular losses to supervise the relative orientation and translation direction between paired images. After training, we evaluate Reloc3r on diverse datasets for both relative and absolute camera pose estimation. For object-level scenes, Reloc3r achieves better accuracy than existing methods, including pose regression, feature matching, diffusion-based approaches, and recent large foundation models. For indoor and outdoor scenes, Reloc3r achieves the best accuracy among all pose regression methods. Our accuracy is also comparable to or even better than feature matching methods, though these methods require significantly more inference time. We also test Reloc3r with causal image pairs. It demonstrates surprising generalization ability, even for cross-modalities such as estimating relative poses between sketches and photos. For indoor absolute pose estimation, Reloc3r achieves the best results among relative pose regression methods. Our accuracy is comparable to absolute pose regression methods. However, while they require separate training for each scene, Reloc3r is generalizable across scenes. For outdoor absolute pose estimation, Reloc3r can achieve close or better results than absolute pose regression methods, even when they are trained on individual scenes separately. Here is a visual comparison of Reloc3r and two representative pose regression methods. The errors are visualized by red lines between the estimated camera pose and ground truth, which are shown in blue and green frustums. We can observe that Reloc3r consistently produces accurate poses. We also test Reloc3r with causal videos, further demonstrating its generalization ability. In conclusion, Reloc3r delivers strong generalization ability, fast running time, and high accuracy. A failure case of Reloc3r occurs when the query image and all retrieved database images are perfectly collinear, creating a degeneracy issue that makes the metric scale impossible to solve. Another limitation is that Reloc3r does not take camera intrinsics as input, so it cannot handle the ambiguity between focal length and distance. Our code and models are publicly available. Thanks for your attention.